Several recent media articles reported that eating dark chocolate reduces your risk of type 2 diabetes. Of course, this made me wonder whether this is just a typical media hype or whether there is any scientific substance behind it. For this video, I took a closer look and reviewed the scientific evidence for you. If you share my passion for either chocolate or diabetes prevention, you will find this video informative and, I dare say, actionable. Welcome to Nourished by Science on YouTube. My name is Mario, and in this video we will talk about cocoa and dark chocolate and their relationship to glucose tolerance and type 2 diabetes risk. Last month, I suddenly saw headlines everywhere proclaiming that dark chocolate could help you ward off type 2 diabetes, or excitedly stating, "How sweet! A daily dose of dark chocolate may cut your risk of diabetes." And when even the New York Times asked whether dark chocolate could reduce your risk of diabetes, I figured I gotta look into this some more. It turned out that the flood of headlines was all based on a new observational study. So we'll review that one first and consider it in the context of the entire available evidence to see whether there is any substance to the hype. Dark chocolate intake is associated with a lower risk of type 2 diabetes. Early last month, a new paper was published based on 3 large cohorts: the Nurses' Health Study, the Nurses' Health Study 2, and the Health Professionals Follow-up Study. Overall, they had data from 111,654 participants from these 3 cohorts. None of these had diabetes at baseline, and they were observed for more than 40 years. During that time, their dietary intakes and other lifestyle factors were assessed every 4 years. This analysis aimed to investigate whether chocolate consumption was related to the risk of developing type 2 diabetes during the follow-up period. Quite an impressive study. Very large, very long follow-up, and repeated assessments of dietary intakes. The key finding was that milk chocolate consumption was not associated with type 2 diabetes risk. However, dark chocolate consumption was associated with type 2 diabetes risk. Specifically, those participants who consumed the most dark chocolate, 5 servings per week or more, a serving being 1 ounce or 30 grams, had a significantly lower risk of developing type 2 diabetes during the follow-up period. In fact, a 21% lower risk in those consuming 5 servings per week or more. Or expressed differently, per 1 serving of dark chocolate per week, the risk was reduced by about 3%. This is certainly a very meaningful difference in risk, and this was after adjustment for other type 2 diabetes risk factors as well as potential confounding factors. What are confounding factors? Well, I'm glad you asked. We'll get to that in a minute. What does a finding like this mean? If we look at some of the media articles written about this study, it seems that some people immediately came to the conclusion that this study proves that dark chocolate causes us to have better glucose tolerance and a lower risk of type 2 diabetes. I certainly don't agree with that conclusion. This was a good study with adequate analyses, but it's just one study and every study has limitations. If there's one thing that is clear from nutrition research and science in general, it is that even the best studies sometimes produce results that are at odds with each other. I'm discussing the limitations of this particular study in some detail in the blog post associated with this video. For now, let me just highlight one potential concern. Imagine that this had been a randomized controlled trial where the 110,000 participants had been randomized to either consume no dark chocolate or varying amounts of dark chocolate over 40 years. That would have been a much stronger study design because in that case, we could be certain that dark chocolate consumption was the only real difference between the groups. This is not the case in an observational study. In fact, in this study, people who ate the most dark chocolate seemed to have a generally healthier lifestyle than those who did not eat any dark chocolate. This is sometimes called the healthy user bias. For example, people eating more dark chocolate had a higher level of physical activity and an overall healthier diet than those who didn't. Now, scientists can try to measure such additional factors and adjust for them statistically, but the concern remains that they may have been unable to reliably measure these other factors well, or maybe there are factors they didn't even think of measuring. So what remains is a risk that we call residual or unmeasured confounding, with confounding meaning confusion of effects. For example, the data don't rule out the possibility that those who ate the most dark chocolate also meditated regularly. And maybe it's the meditation that actually lowered the risk of type 2 diabetes. So when we see the association between dark chocolate and a lower risk of type 2 diabetes, we may think that eating dark chocolate causes us to have a lower risk. But what may really be going on is that the meditation that dark chocolate eaters more often engage in is what actually causes the risk to be lower. I'm not saying that this is the case here, but with an observational study, we can never be 100% certain that something like this is not going on. So yes, an observational study does provide some insights, but I would consider this more hypothesis generating. This means that these results should be used to create a hypothesis that dark chocolate may reduce type 2 diabetes risk. But by itself, this study does not give me a high degree of confidence that this is definitely the case. So what we need to do is look for other studies on the topic. Other observational evidence. We do have data from 2 additional cohorts. For one, the multi-ethnic cohort with about 152,000 participants also found that those eating the most chocolate had a lower risk of type 2 diabetes. In that study, they did not differentiate between dark chocolate and milk chocolate. They looked at all chocolates together and found that those eating chocolate at least 4 times per week and an average of 10 grams or more per day had the lowest risk of developing type 2 diabetes. A second study was much smaller, with about 1,000 participants. Over 30 years of follow-up, those who consumed the most chocolate had the lowest risk of developing type 2 diabetes. Taken together, we have 3 observational studies that describe lower risks of type 2 diabetes in people eating the most chocolate. The data are a bit inconclusive in that 2 studies did not differentiate between dark and milk chocolate, but I'd say together they do strengthen the hypothesis that there may be something about chocolate that could be beneficial for glucose tolerance. Now, why do I say beneficial for glucose tolerance? None of these studies looked at glucose tolerance per se. That's correct. These studies looked at type 2 diabetes risk. But if someone develops type 2 diabetes, this means by definition that they have elevated blood glucose levels. And elevated blood glucose levels only occur if someone is glucose intolerant. And we further know that in the context of type 2 diabetes, glucose intolerance means that the person is insulin resistant and has some degree of beta cell dysfunction, meaning they cannot make enough insulin for their reduced level of insulin sensitivity. If any of this is unclear, check my video about the regulation of blood sugar, linked below, in which I explain all of this in detail. It is clear that if dark chocolate or chocolate in general indeed lowers the long-term risk of developing type 2 diabetes, in other words, if there is a cause-effect relationship underlying the association observed in these observational studies, then we should be able to see an effect of eating chocolate on glucose tolerance, insulin resistance and beta cell function in a short-term randomized controlled feeding study. Let's have a look if we have any evidence for this. The effect of dark chocolate on glucose tolerance, randomized controlled trials. We indeed have data from 4 randomized controlled trials in which investigators assessed the impact of dark chocolate on measures of insulin resistance. 3 of these had an almost identical study design, so let's talk about these first. People with insulin resistance were randomized to one of 2 groups. One group first consumed 1 bar of dark chocolate daily for 15 days, along with their normal diet. After a short washout period where they didn't consume any chocolate, they then consumed 1 bar of white chocolate with the same calorie content, also for 15 days. Fasting blood was drawn at the end of each period to measure insulin resistance. The second group also completed both phases, but in reverse order. We call this a randomized controlled crossover design, and it's a particularly strong study design because we can compare each person's insulin resistance on one diet to their insulin resistance on another diet. Because people were randomized here, we can ensure that everyone consumed dark chocolate in the dark chocolate phase, not just people who otherwise have a healthy lifestyle. Now, what were the results? In all 3 studies, as measured by HOMA-IR, insulin resistance was substantially and significantly lower after participants had consumed the dark chocolate. And in one of the studies, where the researchers also measured insulin secretion in response to an all-glucose tolerance test, beta cell function was also improved in response to eating dark chocolate compared to white chocolate. In that study, the investigators also observed an improvement in glucose tolerance, such that the blood glucose response was consistently lower in response to drinking a beverage sweetened with 75 grams of pure glucose after participants had completed the 15-day dark chocolate phase. One limitation of these studies was that they were pretty short, with each intervention period just lasting 15 days. Fortunately, we have data from a trial in which participants were randomized to either consume dark chocolate, 27 grams or about an ounce per day, or a non-chocolate control with the same number of calories for 1 year. In that study, participants had type 2 diabetes and insulin resistance at baseline. As in the shorter trials, HOMA-IR was significantly reduced in participants after they had consumed the dark chocolate. These are pretty interesting and very consistent results, strongly suggesting that there is something in dark chocolate that is not in white chocolate that improves insulin sensitivity, beta cell function, and glucose tolerance. Let's discuss what that may be. What could it be about dark chocolate that improves insulin sensitivity and glucose tolerance? What is the difference between dark chocolate and white chocolate? Both types of chocolate typically contain cocoa butter, which is essentially just a fat, and both typically contain some sugar, even though white chocolate usually has a lot more sugar than dark chocolate. White chocolate also contains milk, which is usually absent from dark chocolate. The biggest and most obvious difference is that dark chocolate contains the non-fat parts of the cocoa bean in the form of cocoa liquor or cocoa powder. And these contain a wide range of very interesting substances that deserve to be discussed briefly. In general, the substances of interest belong to a very large family of chemicals in plant foods that we often call secondary plant compounds. These are simply molecules that the plant makes that are not strictly necessary for its most basic functions. To us, secondary plant compounds are relevant because many of these have various effects on the human body. A particular group of these secondary plant compounds are phenols, which include polyphenols. There are a lot of other secondary plant compounds, but for now, let's focus on polyphenols. You may have heard of these polyphenols. We find these in many foods, such as olive oil, fruits and vegetables, black and green tea, red wine, and cocoa. Again, there are a number of different classes of polyphenols, but particularly interesting ones in cocoa are called flavonoids. And within flavonoids, cocoa has some called flavanols. And it's the very high flavanol content that many researchers believe could be responsible for the anti-diabetic effect of cocoa and dark chocolate. Now, earlier I shared that dark chocolate reduces insulin resistance and improves beta cell function in randomized controlled trials, leading to improved glucose tolerance. How could flavanols in cocoa be responsible for this? Well, there can be numerous different causes of insulin resistance and beta cell dysfunction, but one commonality that is almost always seen in insulin-resistant tissues and also in dysfunctional beta cells is what we call mitochondrial dysfunction. Mitochondria are the power plants of each cell in which the cell converts fuel, such as glucose and fat, to the chemical form of energy, ATP. We observe that this process doesn't work properly in insulin-resistant muscle cells and insulin-resistant liver cells. And similarly, in beta cells that are unable to secrete enough insulin, we also often find such mitochondrial dysfunction. Another common observation in these cells is what we call oxidative stress, characterized by an accumulation of reactive oxygen species, or ROS. And this is where flavanols from cocoa may come into play. Flavanols are potent antioxidants, and they may be able to deal with reactive oxygen species and remove or reduce their damaging effects on the mitochondria, and that would be expected to improve mitochondrial function. So while no study has ever shown that this is the exact mechanism through which dark chocolate consumption improves glucose tolerance, it's one potential mechanism that is supported by a bunch of indirect pieces of evidence that I have discussed in more detail in the blog post. For here, suffice to say that I think we have a potential mechanism for an effect of dark chocolate on glucose tolerance and type 2 diabetes risk. So another fitting piece in the puzzle. Well, if this is indeed how dark chocolate improves glucose tolerance and reduces type 2 diabetes risk, then we should be able to see similar effects from consuming cocoa in other forms, for example as a beverage. And we can also isolate cocoa flavanols and see if these in isolation affect glucose tolerance. Let's have a look at whether we have studies testing this. The effect of cocoa or cocoa flavanols on insulin resistance, randomized controlled trials. We indeed have data from 6 published randomized controlled trials in which participants consumed a cocoa beverage, usually specifically picked to have a high flavanol content, compared to a control beverage with the same calories but a low flavanol content. And indeed, in 3 of these, we do see reductions in insulin resistance in participants consuming the high flavanol cocoa beverages. The 3 other studies did not detect an effect of drinking a cocoa beverage on insulin resistance. In one of these, however, participants were perfectly insulin sensitive at baseline. And the problem is that even the most skilled mechanic cannot fix a car that is not broken. So I would argue that any effect the cocoa may have on insulin resistance cannot manifest in people who are not insulin resistant. Another study also did not detect an effect on flavanol-rich cocoa on insulin resistance, but that study was extremely short, with participants drinking cocoa only for 5 days, which may simply have been too little time to make a difference. So we only have 1 study out of 6 that was conducted in insulin-resistant people who consumed flavanol-rich cocoa for 4 weeks, which should be long enough, that didn't detect a reduction in insulin resistance. I have discussed these trials in more detail in the blog post. For here, suffice to say that cumulatively, these suggest that in insulin-resistant people, cocoa, when consumed as a beverage regularly over more than just a few days, seems to induce similar improvements in insulin sensitivity as we've seen with dark chocolate. The effect of cocoa flavanols on type 2 diabetes risk. Randomized controlled trials. And lastly, we do have data from a long-term randomized controlled trial in which participants were given either isolated cocoa flavanols in a pill every day or a placebo pill. This study was called the COSMOS trial and included 18,381 older men and women who were free of diabetes at baseline, and they were followed for 3.5 years. The study outcome here was the development of type 2 diabetes. So this was the largest of the randomized controlled trials, and it didn't look at insulin sensitivity, beta cell function, or glucose tolerance, but directly at who did and did not develop type 2 diabetes. And considering how consistent the observational studies and randomized controlled trials we have discussed so far have been, I think it's fair to say that many researchers expected that the cocoa flavanol supplement would lower type 2 diabetes risk. Unfortunately, it didn't. The researchers detected no effect, not even a little hint, that isolated cocoa flavanols had any impact on type 2 diabetes risk. Summary and conclusions. What do we make of this? Well, I'd say that the data on dark chocolate and cocoa are so consistent that I would conclude that eating dark chocolate or consuming cocoa as a beverage does improve insulin sensitivity in people who are insulin resistant, and possibly also improve beta cell function, resulting in improved glucose tolerance and a lower risk of type 2 diabetes. Why the COSMOS trial was null and did not detect any effect of isolated cocoa flavanols remains unclear. Maybe there is more to cocoa than flavanols. If the COSMOS trial had shown a reduction in type 2 diabetes risk with cocoa flavanol supplementation, the story would have been very conclusive. Cocoa in the form of a beverage or dark chocolate improves glucose tolerance and reduces type 2 diabetes risk through the action of the flavanols in cocoa. Now that this trial was soundly negative, showing no effect whatsoever, the story is less conclusive and we remain a little unclear about what it is about dark chocolate and cocoa that exert the effect on glucose tolerance. As a takeaway message, I would still conclude that if you like dark chocolate or cocoa as a beverage, it would seem fine to enjoy these regularly. Just keep in mind that eating or drinking huge amounts every day doesn't necessarily mean a bigger effect. My suggestion would be to have, say, 2 to maybe 4 squares of dark chocolate per day with a cocoa content of at least, say, 80% maybe. I think that dark chocolate could have a particularly positive effect on your diabetes risk and your health in general if it replaces other types of desserts or snacks higher in sugar or fat, such as cookies, cakes, or donuts. If you prefer cocoa as a beverage, that may also be a good option, but keep the sugar content to a minimum. Now, why do I recommend only 2 to 4 squares per day and not more? Didn't I mention that several trials used 1 bar of dark chocolate per day for a couple of weeks? Yes, sure, and I think in those studies, a high dose was probably needed to detect an effect in a relatively short-term study. For long-term, potentially lifelong consumption, I think there are a few other things we should consider. For one, it's important to consider that the sugar cocoa is often consumed with is not great in larger amounts, particularly if you are concerned about blood glucose control. Also, dark chocolate is a food with a high energy density, and as I have explained before, a high energy density means that chocolate has a low satiety score per calorie. In other words, eating too much of such a food could easily lead to an overconsumption of calories and weight gain, and that is certainly not great for diabetes prevention or health in general. And lastly, cocoa can contain a high concentration of heavy metals such as lead and cadmium, and it's very high in the anti-nutrient oxalate. For heavy metals and also oxalates, our bodies can probably manage small amounts, but going overboard and having a bar of dark chocolate or more every day because you now think of chocolate as a superfood could carry some risks. To me, it does seem likely that enjoying a reasonable amount of, say, 2 squares and not more than around 4 squares per day regularly is maybe a sweet spot for your enjoyment of the food with some health benefits while keeping potential risks at a minimum. Okay, that's it for this video. If you found this helpful, I would appreciate it if you could give the video a thumbs up below. Also consider sharing the video with anyone you think may be interested. Lastly, a huge thank you to the first patrons of this channel. If you would like to support the creation of our free evidence-based content, please consider becoming a patron over at patreon.com. Being a patron comes with some perks, such as being able to directly ask me questions about the videos in live calls or a chat community. I've left a link in the description box below. Thank you so much, and take care.